Hello students, in this video we'll see an example of how we can use permutations to count number of arrangements. So let's recall that the number of ways to arrange k things from a set of n with no repetitions is n factorial over n minus k factorial. Or if we expand this out, it's n times n minus 1 times all the way down to n minus k plus 1. And let's see some examples of this. So here's the first example. From 10 members of Congress, four are selected for leadership. With no repetition. How many arrangements are possible? We can just write down the answer with this permutation notation. We can say the solution to this will just be, there's a total number of 10, and then there's going to be 4 that are selected. So those my numbers are actually given to us explicitly in the problem. So this will be 10 factorial over 10 minus 4 factorial, which is 10 times 9 times 8 times 7. And that's our solution. We can also think about this just by writing them out in order, right? So I have 1, 2, 3, 4. Maybe this is president, maybe this is vice president, maybe this is treasurer, and this is secretary, just to make up some arbitrary assignments of leadership. For the president, there's 10 people, so I can draw from 10. Once I've selected one person for president, there's 9 members left, so there's 9 choices for vice president. Once I've chosen vice president, now I've chosen 2 people, so there's 8 people left. So I'll have 8 people available for treasurer, and then 7 people available for secretary, and we see we have exactly the same formulation. So it's oftentimes useful to think about this, and actually the order in which we write down these president, vice president, treasurer, and secretary is immaterial. As long as we have sort of one arrangement of them with no repetitions, the permutation is the way to go. So let's see another example of this. How many different initials are possible if no repetitions among the letters are allowed. So an example of this, for example, MGD, my initials would work, is a valid choice, but A, Alexei Andrei Alexandrov would not be permissible. So we count. So the solution for this problem is we know there are 26 letters in the English alphabet. And then I have P, and from this 26, I have to do initials. Initials are 3 letters long, so I have 3. So this will be 26 factorial over 26 minus 3 factorial, which is 26 factorial over 23 factorial, or 26 times 25 times 24. And again, we can do the same reasoning as above. We can say there's 3 slots. There's 26 letters available for the first initial. That leaves 25, since they have to be, since repetitions are not allowed. Are not allowed. And then 24 for the third. So we can think about these permutations and either actually writing them out with this permutation symbol over here, or we can think about them as just sort of writing down the number of, if I have 3, for example, 3 initials, I want to write down 3 slots and figure out how many elements can go in each slot, assuming that you draw from a set of n, which in this case, in the first case was 10, and the second case was 26. Thank you very much.